Hello everyone, how are you all doing? I hope you're doing well. I've come back after a long time and today I decided to make a video on quantum computing. This is because quantum computing is a very important subject in today's world, especially considering that Microsoft recently built a million qubit quantum computer chip, which is a sign that we're very close to the day when quantum computers take over regular computers. So it's important to understand how quantum computers work and how they are different from regular computers. Firstly, what is a regular computer? A regular computer has these things called bits. These are points of data. They can be either 0 or a 1. This is how bits store data. They can be put through different gates. For example, this one, if we put it through an AND gate, we say, then it will output a 0, since not both of these are 1. These two are different, therefore it will put out a 0. Due to this, computers are very easy to work with, and this bit mechanism, where it can store a 0 and a 1, is very useful, as it means that it's very easy to change the contents of the bit, while also allowing the computer to store vast amounts of information, which is all very well and good. But how are quantum computers different from this? A quantum computer is different in the bits. You see, for example, in a regular computer, this 0 bit can only say the value 0. It cannot say 1, it can't say 999, it can't say any other value. Now, you might say, what if we change it to a 1? And we can do that, for example, maybe by adding 1 somehow. However, then we have a 1 bit, and this 1 bit still only has one value. It can only give a 1 as a value. And that is where quantum computers start to differ. You see, a quantum computer, I've written 1 here, but the 1 doesn't mean anything, because a quantum bit, or a qubit as it's called, I'm going to spell that out, is different because it can store an infinite amount of values. Sure, this qubit can store 1. It's perfectly possible. However, it can also store 0, it can store 0.5, it can store 0.9999998, because if I did too many 9s, it would equal 1. It can equal basically any one of an infinite number of values. Now you might say, what happens when we measure it? When we measure it, it chooses to choose any random value. For example, let us say we have the same qubit and two different people are taking the same measurement, the same type of measurement at the exact same time. One might get the measurement, say, 0, and the other one might get the measurement 1. It's perfectly possible. In fact, a third person might say get 0.5, which doesn't make sense, but that's how qubits work. And these qubits are put through quantum gates, which there isn't really an official name for those other than that. For example, a quantum gate, for example, called AND, a quantum AND, mind you, would take 2 qubits. And the reason it's different is because, again, it's measuring what the qubits decipher, and then it's not putting out a regular bit. No, this is quantum. It's putting out another qubit depending on the state of these two. For example, if they both happen to display 1, it would display a qubit which has a much higher probability of displaying 1, meaning that when a first person and a second person try to see its value, they will likely get 1 because these two are the same. However, not certain. It's perfectly possible that a third person comes along and measures a 0. It's very unlikely, but it's definitely possible. Okay, so that's how quantum computers work. Now, how are quantum computers useful? Firstly, one thing is that quantum computers are gonna be pretty bad in one way if we don't do something about them. This is because quantum computers have the threat of deciphering all our security details and basically letting anyone who has said quantum computer to spy on everyone, take everyone's credit card details, everything. The basic reasoning, is that all our communication and all our everything that's being encrypted all over the world is encrypted through an algorithm called RSA. And the nutshell of how this algorithm works is that it gives everyone one massive large number, which is a prime number, which is not a prime number, but it's the multiplication of two other primes, which are usually smaller, p1 times p2. And the key is that these numbers are absolutely enormous. And while n is used for encrypting, you need p1 and p2 for decrypting. And it takes so long to find p1 and p2 from n that RSA is effectively uncrackable unless you have a quantum computer. Because the details are a little complicated, but in a nutshell, a quantum computer can firstly take a very bad guess for what one of these two is, let's say G, and then, through a complicated process, turn it into a guess that's overwhelmingly likely to be either P1 or P2. And then it can check by dividing n by this P1 to check if it is actually a prime that we're looking for. You might be able to see how this would be bad for the security system. If someone with a quantum computer had a quantum computer, they could find out all the prime factors of the numbers and then decrypt everything from the most top secret security image of the NSA to whatever a terrorist organization is planning. So that's one way quantum computers are pretty bad. Here's a way that they might be good though, AI. You see, due to the fact that they're able to store technically an infinite possible number of values in each qubit, they turn out to be very powerful at processing data. And because of this, guess what type of tech that is very common today needs a lot of data processing and needs to be very fast? That's right, an AI. An AI needs to have a lot of calculations done, because in a nutshell, you have to multiply things with a lot of other things and then add those things to other things. It takes just a lot of computations. However, a quantum computer can not only do these computations faster, but it can do them all in parallel, which means that since all these are different operations, you could have, say, a couple qubits doing one part of it, say 1 times 1, and then another part of the qubits does another part, say 2 times 77, and so on, and you split up the work, and that means that AIs would be able to run ridiculously fast, which means that we could potentially make an AI that's 10 billion times smarter than something like ChatGPT for like half the cost, or maybe a lot less the cost. So that's another way that quantum computers can be used. And one last way, which is very good, is simulations. The reason this is important is because quantum computers can simulate what some amino acids can do to our bodies and whether they help or not. The reason this is important is because this helps us identify proteins and test if they are good or not. Ignore my bad drawing of the protein, pretend it's good. And because they can find out good proteins, they can test these proteins against all types of things, which means that they might be able to find very simple cures to stuff like cancer, to stuff like HIV, to stuff like heart disease and lung disease. And they, by doing this, can help us cure tons of diseases. And therefore, thanks to quantum computers, it's very likely that cancer, AIDS, all these sorts of very dangerous diseases, all of them could be cured due to quantum computers. So that are some of the main ways that quantum computers can be used. In a summary, in this video, we learned what quantum computers are, we learned how they can be dangerous, and we learned how they can be used for good. Thank you.